In this lesson, we are going to discuss about the energy profile diagrams. How can you draw about the exothermic and endothermic chemical reactions? What are the important steps that you need to understand in order to be credited the full marks in your exams? So let's start. First of all, you need to understand the three things to remember. They are very important to understand for the energy profile diagrams. The first rule is simply to understand the energy. Like if we talk about the exothermic reactions, in the exothermic reaction, the reactants energy is higher than the products energy. Why? Because the reactants are having greater amount of the energy, and the products that are made in the exothermic reaction, they are having less amount of the energy. This is the reason the energy is released in the surroundings. As we discussed in the last lecture that the energy of the product should be minimized in order to make it stable. So when we are having the reactants in the reaction, they are already having a large amount of the energy and the product is made. So if the product will be having the same large amount of the energy, that will be unstable. So that condition is not favorable for the compound. And if we talk about the stability, that energy should be released in the surrounding. So in exothermic reactions, the energy of reactants is greater than the energy of products. Now when we talk about the exothermic reactions, so it is understood that in endothermic reactions, the energy of reactants will be less than the energy of products. Why? Because you can also compare with the example that the reactants are not going to start the chemical reaction. They are just waiting for the energy. They are the energy dependent. The reactants are energy. The reactants are not having the sufficient amount of energy to start the reaction. So that's why in endothermic reaction the energy is absorbed from the surroundings in order to fulfill the demand of the reacting particles. Once the demand is fulfilled, so they are ready to undergo information of the products. So this is very important to understand. This is very important because the level of the energy, reactants and the products which you are going to draw in your diagrams, that really matters a lot. So this is the first rule, that the exothermic reactants energy is higher than the products energy. You can remember any one example. Now we also draw the enthalpy change arrow, that is delta H. So as it is in between reactants and products, so it always starts from the reactants. It will be starting from reactants and it ends at the products, regardless of the type of the reaction, either it is exo or endothermic reactions. In both the reactions, when you are going to draw the delta H arrow, you have to start from the reactants and end that arrow to the products. Then we are having the third important concept related with the activation energy. Activation energy is the minimum amount of the energy that is required by the reacting particles to react in the chemical reaction. We can symbolize this activation energy by EA. And you can be asked as well to define the activation energy. So you can define easily, like it is the minimum amount of the energy. It is not maximum, because sometimes the examiner may give you some options related with the definition of the activation energy, mostly in P1. So you are having the statements like the maximum amount of the energy. So it's not maximum, it is minimum amount of energy. So this energy is the minimum requirement, and it is the minimum amount of energy required by the reacting particles. Required by reacting particles. Now what they are going to do, they will be having the minimum amount of the energy. Once the energy is achieved, they will going to be react in the chemical reaction. Reacting particles to react, simple. So this arrow starts from the reactants. The starting point is same for both of these arrows. It will start from the reactants, and if we talk about the ending point, that is different over there. It ends at a hump. the maximum peak of the curve that is basically formed in the diagram. So these are the three rules. If you are going to remember these three points, your energy profile diagram can never be wrong. You won't be credited less than the maximum marks of the diagram. So for example, let's now use these rules in order to form the diagrams of the examples. Now we are having this example number 1, the preparation of the ammonia molecule, and you can clearly see the energy profile diagram, the delta H, which is given it's minus 500 kilojoules per mole. So it shows that it is the exothermic reactions, because minus sign is showing that more energy is released in the surroundings. So that more quantity will be dominating on the nature of the reaction in the energetics. So it is the exothermic reaction. Now more discussing about the first rule in the exothermic reaction, the reactant's energy is greater than the product's energy. So what we are going to do, we are going to draw the vertex of the reactant. So this is the reactant vertex. Now we will start the reaction and will form the smooth curve over there. Now this will be decreasing and form the product, so we can form the product on this side. So you can also give the labeling. These are the reactant particles, this is the reactant side, and the right side is the product one. So in this chemical equation the reactants are given, so better to mention about the reactants. N2 plus 3H2, there are even marks on the labeling, so when you will label properly you will be given complete marks. There is also labeling required on the axis, like on the y-axis there is energy, and on the x-axis there is the progress of the reaction or reaction pathway. These diagrams are also called as the reaction pathway diagrams. Reaction pathway, or you can also label x-axis as the progress of reaction. So this is how you are going to label the reactants and the products. Once you are done with the labeling of the reactants and products, now it's time to draw the arrows, like the arrow of the enthalpy change and the arrow of the activation energy. So let's talk about the first of all the enthalpy change. It starts from the reactants and end at the product. So the reactant, like if I am going to draw the dotted line, so this level is for the reactants and this one is for the products. So your arrow should start from the reactants and it will end at the products. So we will label it as a enthalpy change arrow delta H. In the same way, there is the activation energy. It will start from the reactant and will end at the hump. Hump is the curve, top point of the curve. So we will start from the reactants and will end at the hump. So this is the activation energy arrow EA. This is how we can draw the perfect energy profile diagram for any chemical reaction. Now in the same way we can do it so for this example, in which there is the magnesium reacting with the hydrochloric acid and forms the magnesium chloride and hydrogen. If we focus on the delta H value, it is positive, so this shows that the reaction is endothermic, because more energy is absorbed from the surroundings than the released energy. Now in endothermic reaction, the reactants energy is below than the products, so reactants are having less energy. So let's start with this point. Now it is reactants are having less energy, so I'm choosing the level that is near the x-axis. We will start moving upwards. Now the reaction isn't started, it is just going to increase the energy. Now there is the activation energy reached. Now it can form the products. So let's talk about the products. For example, this is the product level. So the reactants are Mg and HCl. If we talk about the balance, Mg plus 2 HCl, so we can write Mg plus 2 HCl as the reactants over there, and the products are MgCl2 plus hydrogen as the products. So this x-axis, y-axis is the energy and x-axis is the progress of reaction. If you are going to write energy change on the y-axis, you won't be credited for this one. So remember this thing, you are just going to mention about the energy change, energy, not energy change. Energy change is all about the subtraction of the energy. So once you are having the energy values, then you can easily calculate the energy change. So let's draw about the arrows. The delta H arrow start from the reactant to product. So it is reactants and this one is the products over there. So we will draw it as a delta H. And activation energy is from the reactants to the top hump. So it will be going from reactant to top hump. This is the activation energy. So this is how we can like draw the activation energy for any chemical reaction. The most important thing is to use these three rules and to understand them. Once you are going to apply these things properly in your energy profile diagram, you will be credited with all of the marks. Okay, thank you.